There was a controversy between Isaac Newton and Robert Hooke over priority in developing the theory of universal gravitation. Hooke had presented the idea of universal attraction in a 1674 monograph, and his proposal was discussed in the Philosophical Transactions together with observations by other scientists. Nevertheless, after Newton published the Principia in 1687, Hooke's earlier contribution was largely forgotten. When Hooke demanded recognition, Newton reportedly removed many references to him from the Principia and reacted strongly against the suggestion that Hooke deserved credit for the theory. Newton argued that Hooke had merely proposed an idea, whereas mathematicians such as himself had performed the calculations and supplied the demonstrations needed to transform speculation into science. Evidence cited by David Gregory indicates that Newton had already developed important elements of his gravitational and planetary theory in a manuscript written before 1669. This manuscript suggests that Newton had independently investigated the gravitational attraction of the Moon toward the Earth and of the planets toward the Sun. Newton therefore rejected the accusation that he had learned the inverse square relationship from Hooke. He described Hooke's formulation as a guess because Hooke had not provided a mathematical proof or demonstrated that the law followed from observed phenomena. Newton also stressed that Hooke himself had admitted in 1674 that he had not experimentally determined how gravity decreased with distance and had invited others to continue the investigation. Supporters of Newton consequently maintain that only Newton possessed the mathematical ability required to write the Principia and establish a complete theory of gravitation. Some historians acknowledge that Hooke sketched important ideas before Newton, but argue that later interpreters attributed more precision to Hooke's words than his original work justified. Other scholars, however, have continued to defend Hooke and emphasize his substantial contributions to theories of gravity, planetary motion, and curved trajectories. They argue that Hooke should not be judged solely by the standards of Newton's later mathematical demonstrations. Hooke was often regarded as a practical or mechanical genius rather than as a theoretical scientist, a distinction that placed him at a social and intellectual disadvantage. His lower social status also separated him from prominent gentleman scientists such as Robert Boyle and contributed to the limited recognition of his achievements. Newton, despite his exceptional mathematical abilities, was criticized by some contemporaries for dogmatism, excessive confidence, and discourteous conduct in scientific disputes. More recent studies have re-evaluated Hooke as a capable mathematician whose work must be understood in the broader context of his numerous scientific and technical interests. Schopenhauer went even further, claiming that Hooke had already expressed the central conception of universal gravitation and that Newton's principal contribution was to verify and develop it through calculation. The controversy, therefore, remains unresolved in a simple sense, revealing how scientific discoveries emerge through a combination of original insight, mathematical proof, experimental evidence, personal rivalry, and the social structures that determine who receives historical credit.